All the stars we see, including our sun, are in a balance of powers. Stars are very heavy objects, so they have strong gravity, which presses them from the outside and makes them shrink. But inside a star, while it burns fuel, there are nuclear reactions that produce incredible amounts of energy. This energy is the light and heat that we feel during the day. But most importantly, these reactions increase the pressure inside the star and create a force that is fighting with gravity. So as long as the star has a full tank, it's safe. But then, the fuel runs out, the pressure inside the star falls, and the gravity wins. A star the size of our sun can shine for about 10 billion years. Specifically, our lovely sun is about 4.5 billion years old and has already burned half its fuel. The next stage in a star's life comes when it runs out of juice. Internal pressure drops, but gravity continues to press. At some point, a star simply collapses under its own weight and shrinks to the size of its core at the speed of almost a quarter of the speed of light. In less than half a second, a huge star turns into a small and dense object. This rapid collapse creates incredible shock waves that cause the upper layers of the star to explode. Now, an incredible amount of energy and matter is thrown into outer space. At this moment, luminosity of the star increases millions or even billions of times. This is the flash that our scientists can see with super powerful telescopes. But the light from this explosion doesn't reach our planet until many years later, so in fact, this star has long since faded. There are several options at this point. It all depends on the size of the star. If its mass is small, about the mass of our sun, then for several months, this flash will become brighter and brighter until it reaches its peak. Then, the energy of the explosion will begin to dissipate, gradually fading and cooling down. A few years will pass, and the temperature of the former star will match that of space, and it will simply cease to exist. But the heavier the star, the more interesting the events will be. Heavy stars burn their fuel too quickly and have a much shorter lifespan. Stars weighing about 8 masses of the sun can collapse into a rather unusual object, which is rarely found in the universe, a neutron star. This dull ball is only 6 to 12 miles wide and covered with a hard metal crust about half a mile thick. Neutron stars can weigh about 2 suns and have a strong gravity force. If you feel comfortable and in good shape on Earth, you wouldn't even be able to lift a needle or a match here. What's more, you would be pressed to the surface like a pancake and just unable to move. But there are stars dozens of times heavier than the sun. An explosion of such a supernova, which weighs at least 40 times more than the sun, gives birth to the most inexplicable and mysterious object in the universe, a black hole. At first, an incredibly bright explosion occurs. A shockwave spreads, carrying dust and matter of the former star around like a fog. And at the place of the explosion, only a small black disk is left. This black abyss is the heaviest object in the universe. It's so heavy that its gravity curves space-time around it. Yes, the closer you are to a black hole, the slower time will go for you. If you could get close enough to one of them, spend a couple of minutes in its orbit, and return to Earth, you would simply not recognize your home. 1 minute near a black hole can be a month, a year, or a decade on Earth. This depends on how heavy the black hole is. But don't get too close. The force of its gravity is so strong that even light can't escape from it. Humanity also knows about the existence of supermassive black holes. They gradually build up their mass, feeding on different cosmic objects just like a predator. Usually, such supermassive black holes lie in the centers of galaxies, and their gravity is so strong they can hold countless stars near them. For example, this is the only photo of a black hole, which is located in the center of the Messier 87 galaxy. The orange glow around it is its event horizon. That's the remains of the light from the objects this black hole has swallowed. You're quite safe though. The closest black hole is 1,120 light-years away. But supernovae can explode not only when gravity wins the fight with the star's internal forces. Sometimes the opposite happens. The nuclear fusion inside the star begins to affect much more matter than normal. The pressure inside a star increases, and it defeats the force of gravity that exerts pressure on the star from outside. At this point, there's a boom! This never happens by itself, and this type of supernova is only possible in binary star systems. Two stars are spinning around each other. One star begins to swallow the substance from the other. Then, the nuclear reactions inside it are no longer in balance, and a supernova explodes. For some time, scientists believed that such an explosion could occur in 2022. There's such a binary system in the Swan constellation at a distance of 1,800 light-years from the Sun. The luminous red nova should have occurred here. Such a red flash would have been visible to the naked eye for months. And after the explosion itself and the merger of two stars, a new, hotter, and heavier star was to appear in their place. But a new analysis of the data revealed a calculation error, and this event will not happen soon after all. So now we see that a supernova explosion is a very dangerous event, and it can cause great harm to our planet if it happens close enough. The main danger is gamma rays. This is the radiation that comes from the explosion. When these rays reach the Earth, they affect our space shield, the atmosphere. They reduce the ozone layer and make us vulnerable to solar radiation and cosmic rays. In this case, all life on the planet is in incredible danger. And the bad news is that such an explosion could happen quite soon. Betelgeuse, the brightest star in the night sky, about 17 times larger than the Sun and 8.5 billion years old. It's begun to exhaust its fuel reserves. Scientists predict that this giant will explode like a supernova at any moment within the next 10,000 years. So it may happen in a few centuries or even tomorrow. Everything will happen as follows. Betelgeuse will collapse in a fraction of a second, and then it will explode so brightly that it will look like a second moon in the night sky. We will observe a new bright spot in the sky for weeks or even months. But then, it will begin to fade until it completely disappears. Not without a trace though. In its place, there will be a neutron star, weighing 1.5 times the Sun. It will be one of the biggest events that humanity has ever seen. Still, we have nothing to be afraid of. Betelgeuse is about 550 light-years away from us, so its X-rays and ultraviolet light will not affect us. A much greater danger is posed by the release of material that occurs in a supernova explosion. But this shouldn't make you worried either. The shockwave won't reach the Earth until 6 million years later, and it will be suppressed by the oncoming solar wind. So if we see Betelgeuse explode today, it will be an epic sight. But in fact, the star will not exist at the time, because it will mean the event itself happened almost 6 centuries ago. It's just that now the light from it has reached us. Some scientists believe that the Ordovician Silurian extinction events, which occurred almost 500 million years ago, happened exactly because of a star explosion. Then, almost 60% of marine vertebrates went extinct. Yet, it was not a supernova, but a hypernova. That is what scientists call explosions of stars 100 to 150 times larger than the Sun. In addition to the abnormal weight, the star must rotate very quickly. Such objects are very rare. In our galaxy, there are few of them, and scientists believe that hypernovae occur about once in 200 million years.
Now, I don't want to freak you out, but something bizarre has erupted in the depths of space. It was an explosion brighter than billions of suns. But the real mystery is that it doesn't match anything astronomers have ever seen. Usually, cosmic events like this follow familiar patterns, but not this one. It's a cosmic anomaly. This strange cosmic explosion has left astronomers totally baffled. It could be a super rare event where everything lines up just right, or it could be something completely new, never seen before. This event was first detected by an X-ray space telescope called the Einstein probe on April 8, 2024. It first appeared to be a regular gamma-ray burst. Those typically give off incredibly bright X-rays. But could the answer really be so simple? Something didn't add up. Now, gamma-ray bursts are the most powerful explosions in the universe, and they can happen in unusual ways. Long-duration gamma-ray bursts are caused by the demise of massive stars that spin incredibly quickly. When these stars run out of fuel, their cores collapse under gravity, forming an extremely dense object, like a black hole. At the same time, the outer layers of the star are blown away in a massive explosion called a supernova. Gamma-ray bursts are followed by jets. Those are twin beams of material shooting out from opposite sides of the collapsing object. They're super fast, moving at nearly the speed of light. These jets appear brighter if they're pointed directly at us. It's like how a flashlight beam is brightest when it's aimed straight at you rather than at an angle. Now back to our unusual cosmic explosion. Remember me telling you something wasn't adding up? Hey, it was just 45 seconds ago. Well, the problem was that when multiple telescopes observed this event in different wavelengths – ultraviolet, optical, near-infrared, radio, X-rays, gamma rays, you name it – it didn't match any known type of event. The most likely explanation, according to current research, is that this explosion is the result of a white dwarf star being torn apart by a medium-sized black hole. And still, it's not so simple. Now, black holes are areas in space where gravity is so strong that nothing, not even light, can escape. That's why they're called black holes. It's believed that stars with at least 3 times the mass of our Sun can collapse under their own gravity once they run out of their stellar fuel. When a star has so much mass packed into such a small space, its gravity becomes so powerful that it forces everything, including atoms, to squish together. This intense density leads to the formation of a black hole. So, when a white dwarf star is torn apart by a medium-sized black hole, it results in a high-speed jet of material that can be aimed directly at Earth. So, could this space disaster be the reason behind our mysterious event? Unfortunately, even though it ticks some boxes for several types of phenomena, including the one involving a white dwarf, it still doesn't fit all the criteria for any of them. The event's short duration and high luminosity are hard to explain using any scenarios we can produce. So, does it mean we have come across something completely new? The universe is full of energetic flashes caused by outbursts from stars and black holes, supernova explosions, stars being eaten by black holes, and other cosmic events. Astronomers usually figure out what these events are by analyzing their duration, frequency, source, and the specific combination of wavelengths they emit. Here, I just have to say a few words about the instrument that discovered the space anomaly. The Einstein probe is an X-ray space telescope project led by the Chinese Academy of Science in collaboration with the European Space Agency and the Max Planck Institute for Extraterrestrial Physics. That's a mouthful. This project is all about studying high-energy space events over time. Its main goal is to find inactive black holes and figure out how matter falls into them by spotting X-ray flares produced by these sudden space events. The Einstein probe also hopes to catch the electromagnetic signals from events that cause gravitational waves, like when neutron stars merge. It also keeps an eye on the whole sky to spot all kinds of space explosions and track already known changing X-ray sources. After the Einstein probe detected that ultra-bright space flash, the event was also observed by a few other ground-based and space telescopes, including the Nuclear Spectroscopic Telescope Array, SWIFT, Gemini, Keck, Dark Energy Camera, Very Large Array, Australia Telescope Compact Array, and Neutron Star Interior Composition Explorer. That's a bigger mouthful. Using all this data, astronomers pieced together the event's characteristics, but it didn't make the case any clearer. Quite the opposite. It just deepened the mystery. This event flared up in soft X-rays for the first 10 seconds, then plateaued at a steady glow for about 4 days before fading quickly within another day. This is much longer than typical gamma-ray bursts, which usually last from a few milliseconds to several hours. But it was still not long enough to fit into other known categories. The event's brightness in X-rays was also unusual. It was too bright for some types of phenomenon, but not bright enough for others. The most puzzling part is that the Very Large Array didn't detect any radio emission from the source when it was observed 11 days, 158 days, and 258 days after the initial flare. Now normally, when something this bright in X-rays lasts for this long, it's usually associated with a luminous radio counterpart. But in this case, no radio signals were detected, which is very strange and adds to the mystery. Astronomers didn't give up and considered several other possibilities, like fast blue optical transients. Those are a new class of explosions that release huge amounts of energy and blast matter into space at incredibly high speeds. These bursts are so powerful that one F-bot can be at least 10 times more powerful than a regular supernova. Fast blue optical transients do look like supernova explosions, but they are much faster. They flare up and fade away much more quickly than regular supernova. They're also much hotter, which makes the light seem bluer compared to other supernova. Since these explosions happen so quickly, it's tough to figure out what causes them. In January 2019, astronomers narrowed it down to 2 causes: a black hole consuming a white dwarf star, or a rare kind of supernova that leads to the formation of a neutron star or a black hole. Now, another explanation for our mysterious space explosion, and astronomers think it's the most likely one, is a tidal disruption event. It happens when a black hole swallows a star, causing a flash of light. When a star gets too close to a supermassive black hole, it doesn't get off easily. No, the black hole's powerful tidal forces tear the star apart, breaking it into pieces and pulling it toward the black hole. Its remains turn into a stream of debris that falls toward the black hole's accretion disk. However, before the debris settles into the disk, it overshoots the black hole in an elliptical path, only to be pulled back in. At one point in this path, the debris collides violently with other parts of the star being pulled in, and that's when we start to see the first bursts of emissions. In some rare cases, tidal disruption events create huge jets of material that shoot out from the black hole's poles. If these jets happen to point directly at Earth, we can see the signature of the event. It often looks like an intermediate mass black hole eating a white dwarf star. However, there should still be some radio emissions coming from the jet of a tidal disruption event. The reason none have been detected yet might be that the event was likely observed too early. Previous studies suggest that it can take hundreds or even thousands of days for the jet material to slow down enough to start sending out radio signals. If future observations pick up radio emissions, it could help solve the mystery. But if there are no signals, it might mean it's a very unusual gamma-ray burst or something completely new that we haven't seen before. What if the sun went boom? Well, you can guess it would be super bad news for us. This was sure a short video, huh? Nah, wait, I have more. If the sun blew up, chaos would ensue in our solar system. But scientists tell us that it will certainly happen one day. But why? How exactly would events unfold? And is it possible for us to somehow survive this event? Hey, let's delve into it. First of all, get ready for a journey to the Sun's core. The Sun's heart is packed with hydrogen atoms, having an out-of-this-world dance party. These atoms are so excited that they smash into each other with all their might. And when they collide, something magical happens. It's called nuclear fusion. And in this fusion fiesta, the hydrogen atoms combine to form helium atoms, a chemistry experiment on a grand scale. During this nuclear fusion, a teeny bit of mass from the hydrogen atoms is transformed into a massive amount of energy. It's Einstein's famous equation E equals mc squared coming into play. Energy is unleashed in the form of light and heat, radiating outwards to brighten up the entire solar system. And once all these processes get going, a bunch of energized particles called photons join the fun. These photons are like tiny packets of light, bouncing and zipping around in all directions. They play a crucial role in carrying the sun's energy through space, illuminating our world and warming our cozy planet. But to keep all this going, so that atoms don't escape and create complete chaos, the sun's core needs to be under tremendous pressure. This pressure comes from the immense weight of the sun's outer layers pressing down on the core. The outer layers are squeezing the inner core. But the inner layers don't give up. The energy created from fusion and the bustling photon party tries really hard to escape the sun's core. But the core is so dense, like me, and the pressure is so big that the energy takes its sweet time to make its way out. It bounces around, gets absorbed, and re-emitted by other particles. Eventually, after a long time, it reaches the sun's surface and zooms off into space, reaching us as sunlight. So now you know how the sun works. Now, what happens once it reaches the end of its life? Well, here's the twist. Our sun has a limited supply of hydrogen fuel. In about 5 billion years, it'll run out of its fuel. After that, the star will undergo some big changes. Now, pay attention, because there's a pretty good chance we're all going to miss this. First, the sun will puff up and become a red giant, exploding like a balloon. It will grow so big that it will swallow up the inner planets, including our beloved Earth. Talk about a sun taking up all the space. So we won't even see the end of our sun unless we move somewhere further away. After the red giant phase, the sun will shrink a bit. Its outer layers will fade away into space, leaving behind a beautiful planetary nebula. It'll be revealing its glowing core. Ooh! The core, now filled with helium,
will start sounding weird.
And will start fusing heavier elements like oxygen and carbon. These reactions won't be as energetic, like a party with less dancing and more chill vibes. Eventually, even the helium will be used up, and the sun will become a compact white dwarf, a stellar retiree enjoying its retirement home. Scientists estimate that the sun has about 7 to 8 billion years left before it dims its lights. Don't worry though, by that time, humanity might have traveled to far-off galaxies, or maybe even evolved into amazing space beings. So our sun won't go out with a bang like fireworks. It's not big enough to become a supernova or a black hole. Those stellar superstars need way more mass than our sun to pull off those cosmic tricks. But what if it blew up very suddenly, just like an abrupt event without any reason? Well, let's see. Imagine this. The sun goes boom, and Earth is in for a wild ride. The event unleashes an insane amount of energy, sending a shockwave racing through space at the speed of light. It takes about 8 minutes for this shockwave to reach Earth. Why? Well, the sun is a whopping 93 million miles away from us on average. So it takes a little over 8 minutes and 20 seconds for the sun's light to travel all that distance and reach us. But let's talk about the event itself. It would be a great sight to witness, but sadly, it would also be the end. Roll credits. The crazy amounts of unleashed energy would cause the sun to expand rapidly, again swallowing up the inner planets, including our Earth. And that's not all. Brace yourself for a massive burst of radiation. The sun would unleash a torrent of supercharged particles. We're talking about X-rays and gamma rays, the kind that can seriously mess things up. When these high-energy particles hit the atmosphere, they go wild, causing all sorts of chaos. They ionize the atmosphere, creating a ginormous electromagnetic pulse. This pulse is like a shockwave for electronic devices. It fries them, zaps them, and leaves them useless. So if your gadgets aren't protected, they're in for a rough time. Speaking of rough times, after that, it's instant vaporization for our planet. But the sun's grand finale just doesn't mess with Earth. It wreaks havoc on the entire solar system. That massive burst of energy would be crashing into everything in its path. Planets and other objects get knocked off of their cozy orbits, causing chaos and unpredictability. The asteroid belt between Mars and Jupiter, kapow! It's gone, obliterated, or scattered to the cosmic winds. And even planets that will survive this event will probably go off their orbits to wander somewhere. And let's not forget about the outer planets, like Jupiter and Saturn. These giants generate their own internal heat, which keeps them cozy and attracts lots of moons. But the sun's boom would steal their warmth, turning them into incredibly cold places. And now that we've discussed how catastrophic all this would be for everything in our solar system, let's ask the logical question: can humanity make it? The short answer is nope, we wouldn't make it. Everything would be wiped out, except maybe some sneaky bacteria hiding in the shadows. But in a crazy scenario where the sun gave us a heads up about its plans, we might have a fighting chance. If we knew in advance and had time to prepare, we could get our survival gears turning. So what could we do? Since Earth itself won't survive the sun's tantrum, we'd have to move somewhere. Remember how we mentioned that not all planets would be completely destroyed? Well, sadly, the ones closest to the sun, Mercury, Venus, and Earth, would disappear. So the easiest option would be to move to some other solar system with its own Earth-like planet. But what if the Earth somehow managed to survive this catastrophe? Let's not think about how it happened and just discuss the consequences. Well, our climate would go crazy. During the first moments of the sun's kaboom, the radiation and particles would crank up the temperature big time, like a never-ending heat wave. We're talking major greenhouse effect. The oceans would evaporate, creating thick, fluffy clouds that trap heat and refuse to let it escape into space. And after that, without the sun's warm embrace, the Earth would quickly become an icy freezer. So we'd have to think outside the box. One idea would be to take shelter deep underground, where we won't be that much affected by radiation and sudden temperature changes. As you dig deeper, the temperature rises. So, with the right tools and resources, humanity could hunker down in fortified bunkers, surviving for a couple of years without the sun's rays. Why just a couple of years? Well, remember how we said the sun is a gravity center of our solar system? Without it, Earth would be adrift in search of a new center of gravity. Imagine our planet, our trusty satellite, the Moon, and all the other planets slowly floating away into space. Luckily, our trusty sun is hanging in there, keeping us warm and shining for many more cosmic adventures to come. So, we're safe for a few billion years. But it's always fun to imagine impossible scenarios. So stay tuned for more what-ifs.
More than 1 million Earths can fit in our sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. The chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. Many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. But traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot, since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation. And once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the Moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our Sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us.
NASA sent a spacecraft right into the sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast when it happens, The influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the Moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the Moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the Moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the Moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the Moon and spend 1 lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket.
Imagine you're looking up at the sky on a clear night, and you see all those beautiful stars twinkling up there. Well, one of them is Betelgeuse, a celebrity among stars. If you want to catch a glimpse of it, look up at the Orion constellation. It low-key looks like an archer holding a bow, and you can spot Betelgeuse as the reddish-orange dot on their shoulder. It's one of the brightest stars in the sky, so it's hard to miss. Betelgeuse is not your ordinary star. First of all, it's gigantic, up to 1,000 times the size of our Sun. Can you imagine that? It's so enormous that if we could somehow replace our Sun with Betelgeuse, it would engulf all the inner planets, including Earth. And here's another fun fact. When we look at Betelgeuse, we're actually looking back in time.
Yep, you heard it right.
Betelgeuse is about 600 light years away from us, so the light we see today actually left the star 600 years ago.
It has quite a history. This star has been shining brightly for millions of years. Long, long ago, even before smartphones and telescopes, ancient Sumerians were the first to spot Betelgeuse in the sky, and it's been a diva this entire time. For example, in 1866, Betelgeuse became one of the brightest stars in the night sky. It was so dazzling that people could see it even during the day. Astronomers all around the world went bananas documenting this extraordinary event. Since then, Betelgeuse has been playing hide-and-seek with us. It all started when Betelgeuse started to dim back in 2019. Since then, it likes to dim and brighten sporadically. But these changes in brightness tell us about something important. As we mentioned, Betelgeuse was always a bit of a troublemaker. It's been living a fast and furious life. Because of that, it has been burning its fuel at an incredibly fast rate. The changes in the star's brightness are clues that Betelgeuse is approaching the end of its life cycle. The drama intensified when the Hubble Space Telescope snapped jaw-dropping images of Betelgeuse, like it was getting ready to blow its top. All this made scientists think that the star is close to retiring in a dramatic way. It's about to go supernova. So picture a star partying hard, powered by the fusion of hydrogen atoms. It's like the star's own energy drink, but just like any party, the fuel starts to run out. That's when things get interesting. As the star guzzles up its hydrogen fuel, it slowly begins to run on empty. It can't sustain itself anymore. So now, it's time for the grand finale. This finale is called supernova. The star collapses in on itself like a deflating balloon. The pressure and temperature inside skyrocket to mind-boggling levels, and this celestial tantrum triggers a colossal bang. So you can see why observing Betelgeuse is like having a front-row seat to the spectacular drama. But here's the big question. When will this happen? Well, the answer is not as simple as setting a timer. You see, stars have their own schedules, and Betelgeuse is no different. It could be tomorrow, or it could be thousands of years from now. Scientists have come up with only a rough estimate. They believe that Betelgeuse will go supernova within the next 100,000 years. Quite a spread, huh? Sure, that sounds like forever to us, tiny humans. But in the vastness of the universe, it's just a blink of an eye. But there's a chance, just a tiny chance, that Betelgeuse could surprise us all and go supernova much sooner. Considering its dips in brightness, we might be in for a show within the next few hundred years. We'll just have to wait and see. Now, if Betelgeuse does go kaboom, what will happen? Well, get ready for a show like no other, folks. When a star collapses under its own weight, it unleashes a cosmic firework of epic proportions. The star releases a crazy amount of energy in the form of light and heat. Betelgeuse's supernova is going to be extra special. It's like the superstar of supernovas. It will shine so brightly that it might even outshine the other stars in the sky. Picture that, Betelgeuse stealing the spotlight. The show could be so bright that you won't need a telescope to catch a glimpse. Nope, you'll be able to see it with a naked eye. It might even be visible during the day, making the sky look like it's hosting the coolest rave ever. After that, the supernova will keep us entertained for weeks. It will be like having a second moon in the sky, shining as bright as the full thing. Imagine that, 2 moons dancing together in the night. After several weeks of lighting up the night sky, Betelgeuse's supernova will slowly fade away, but it would leave behind a souvenir, an ethereal remnant. It's like a fading memory of the star's epic performance. This remnant, too, would slowly fade away over the course of several months. But it's not just about the light show. The boom will send out powerful shockwaves, and we might actually feel them right here on Earth. It's like the universe giving us a gentle tap on the shoulder, saying, hey, look at this amazing spectacle. How dangerous will it be for us? Well, we know that Betelgeuse's supernova would send dust and gas shooting into the atmosphere. It's like a big space sneeze. And this sneeze could cause a decrease in global temperatures. We're talking serious climate impact here. It could even lead to a mini ice age. But these are just assumptions. We don't know for sure if the consequences will really be that serious. But, of course, we want to be prepared for this event just in case. That's why scientists are studying Betelgeuse closely. But, in addition to serious scientific research, astronomers also have a blast of celestial comedy. Jokes are flying left and right. Someone has even created a Betelgeuse status account, which you can check yourself. So, as you can see, the star is keeping us on our toes. Astronomers keep observing it, and they need our help too. They want us to keep an eye on Betelgeuse and report any changes we see. How do you do that? First off, channel your inner astronomer and observe Betelgeuse. Take a peek at the star and note down what you see. Is it twinkling, shining, or feeling a bit dim? Jot it all down. Then be a superstar yourself and report your observations to the astronomers. Your observations will help them track Betelgeuse's journey towards its big supernova moment. You can also join in on some citizen science projects. They're super fun and easy, trust me. One cool project you can jump into is the Betelgeuse Brightness Monitor. By participating, you help scientists keep tabs on how bright Betelgeuse is shining. Your contribution can make a real difference. So join the monitoring team. You'll be part of something amazing, and who knows, your observations might even help predict when Betelgeuse will show off its supernova magic. By doing that, we can assist them in monitoring this superstar and learn more about the fascinating world of stars. But that's how we can help scientists to predict this event. Now, how can you personally prepare for it? First things first, you'll need the right gear to catch all the supernova action. A trusty telescope is like your front row ticket to the starry show. It'll bring you up close and personal with Betelgeuse's performance. And remember, you'll need special eyewear to shield your eyes from the intense burst of light. Safety first. And of course, prepare in case it decides to mess with our climate. Stock up on essentials, like warm clothes and supplies, just in case we experience a mini ice age. But let's just hope it won't happen. So keep your eyes on the night sky, my friends. Betelgeuse may not be ready to blow up just yet, but when it does, it will be a sight to behold. Until then, let's enjoy the twinkling stars. And remember, there's always something extraordinary happening in the vastness of space.
Now, it's been a long time since there was a supernova in the Milky Way. Over 400 years to be precise. So hey, we're long overdue. So here are the most likely stars to go boom, if they haven't already. At the top of the list must be the Southern Hemisphere star Eta Carinae. Greek letters before the name of the constellation indicate the rank of the star's brightness in that constellation. Sir Edmund Halley, in 1677, recorded Eta Carinae as the 7th brightest star in the constellation Carina, Eta being the 7th letter in the Greek alphabet. It might not have looked very bright to Sir Edmund and his contemporaries in the 17th century. but modern studies of Eta Carinae estimate it's 5 million times more luminous than our Sun. Luminous is a technical word astronomers use. It doesn't just mean brightness. Luminosity refers to the total energy released at all frequencies. Eta Carinae releases 5 million times more energy than the Sun. Truly one of the whoppers of the Milky Way, Eta Carinae is 100 times more massive and 240 times larger than our yellow-white dwarf sun, Sol. Obviously, since it appears dim, Eta Carinae is pretty far away, about 7,500 light-years away. Yet even at this distance, if this star goes hypernova, it can still impact Earth's ozone layer, disrupt satellite communications, and harm astronauts. 159 years after Halley's observation, Eta Carinae experienced a nova-like explosion. It increased from a relatively dim star to become the second brightest star visible from Earth, but only for a period of 27 years. From 1836 until 1863, Eta Carinae was the second brightest visible star after Sirius, the dog star, and Sirius is only about 8 light-years away. Since 1863, aside from a couple of flare-ups, Eta Carinae has dimmed back down to its original brightness at magnitude 4.5. Now, astronomers owe us a small apology, which we don't expect to get anytime soon, for star magnitude nomenclature. The brighter a star is, or planet, or moon, the lower its magnitude. Thus, stars brighter than first magnitude are either 0 magnitude or negative magnitude. The full moon, for example, is magnitude negative 13. A magnitude positive 4.5 star, like Eta Carinae, is quite dim as seen from Earth, but it's clearly visible in a night sky without light pollution or clouds if you live anywhere south of the latitude of Cairo, Egypt. 30 degrees north latitude is the farthest north you can see this star. Now, listen up. Eta Carinae is currently up to something. It's been brightening again and is now brighter than at any time since 1864. It's a complex situation. Eta Carinae is really 2 stars, Eta Carinae A and Eta Carinae, what's your guess? Oh, B. There's a third star nearby that's also interacting with the double star's dynamics. Now, without looking, I'm guessing it's named Eta Carinae C. Good guess. Blown out into 2 incredibly massive globes of gas that are expanding at 20 million miles per hour, Eta Carinae is, without a doubt, one of the strangest looking stars you'll ever see. Remember, it's located at a great distance of 7,500 light-years away from us. And if anything had happened to Eta Carinae in the last 7,500 years, like going hypernova, we wouldn't be able to see it, because none of Eta Carinae's electromagnetic radiation would have gotten here yet. Astronomers are keeping a close watch on Eta Carinae because it can go hypernova at any time. Or maybe it already did 5,000 years ago, in which case we'd only have to wait another 2,500 years to see it. Yeah, like I'll put it in my planner. Now, from a list of over 30 likely candidate stars that might go supernova, Rho Cassiopeiae is many astronomers' choice. Another Greek letter, Rho, is the 17th letter in the Greek alphabet. It means that Rho Cassiopeiae is the star with the 17th brightest apparent magnitude in the constellation Cassiopeia. Yet Rho Cass, a nickname, is only one of 7 known yellow hypergiant stars in the Milky Way. It's another whopper. To be seen at magnitude 4.5 from a distance of about 10,000 light-years away, Rho Cass must be a very large star, a hypergiant. Placed where the Sun is, Rho Cass would encompass the orbit of Mars. But it's still yellow. It's not a red giant star. Red indicates a cooler surface temperature. Rho Cass, as huge as it is still as hot on its surface as our Sun, or even a little hotter. That can only mean 2 things. Deep inside its core, Rho Cass is fusing atoms much heavier than hydrogen or helium. Plus, Rho Cass is producing much more energy than a red giant star. In the year 2000, Rho Cass erupted massively. It brightened by 2 orders of magnitude as it ejected 10,000 times the mass of Earth into space at 4 times the speed of sound. Astronomers detected the signature of titanium oxide in this eruption. This means that Rho Cass is much closer to going supernova, or in this particular case, hypernova, than astronomers used to assume. Iron is just a few steps above titanium in the periodic table, and when iron forms, fusion stops and a star collapses. Rho Cass is really close, or more correctly, was really close, because the eruption we saw in the year 2000 really happened 10,000 years before. Many astronomers think Rho Cass has already gone hypernova, formed a black hole, and doesn't even exist anymore. Meanwhile, Betelgeuse caught everyone's attention not so long ago. The star, not the movie. It dimmed dramatically, appearing only 37% as bright as it usually is. Is it getting ready to go supernova? Betelgeuse is by far the brightest star in the whole sky, in infrared light. This is an important fact because it relates to Betelgeuse's status as a supernova candidate, as we shall soon see. Betelgeuse is also named Alpha Orionis, another Greek letter designation. So we should conclude that Betelgeuse is the brightest star in Orion, right? Wrong. It's the second brightest star in its constellation. Rigel, or Beta Orionis, is the brightest one in that region. Figure that one out. It may be because Betelgeuse is classified as a semi-regular variable star, which sounds kind of redundant to me. Its approximately 400-day cycle of pulsation changes its brightness by about one full magnitude, going from much brighter than a first magnitude star to closer to a second magnitude star. But never was Betelgeuse observed to dim so rapidly or so drastically as it did recently. So what's going on with it? Well, from late 2019 to mid-2020, Betelgeuse went through a period of substantial dimming during a mass ejection event. The world astronomy community jumped on the situation, and in the course of their investigations, they came up with some surprising new factual data on Betelgeuse. First, Betelgeuse is not as far away as we once thought. The new, more accurate distance for Betelgeuse is 548 light-years. That's 25% closer than previously measured. The second new fact, Betelgeuse's diameter has been reduced by the same percentage. The star is now known to be 25% smaller than previously believed. The cause of Betelgeuse's dramatic dimming was also determined. The giant star ejected a cloud of gas that contained magnesium. The cloud blocked a large portion of the light coming from Betelgeuse and made it appear visually much dimmer than it really was. Magnesium is not halfway to iron on the periodic table, which means Betelgeuse is not as far along on the path to a supernova as was suspected previously. When iron starts forming in the star, it means that this star is close to shutting down its fusion reactions. The next step is implosion. We aren't quite there yet with Betelgeuse. This star emits most of its energy as infrared light, and it also indicates that its core is most probably still burning helium, and not something that would greatly increase the amount of heat, like carbon for instance. Betelgeuse will still go supernova, but not for another 100,000 years. So you can cross it off your supernova list for the time being. And as for how to correctly pronounce Betelgeuse, you can say it any way you like. There are as many different pronunciations out there as there are people who think they know how to pronounce it correctly. Now, supernova 1987A caught astronomers off guard when it lit up the large Magellanic Cloud 100,000 plus light-years away from the Milky Way. That's when attention was turned to a similar star much closer to Earth, Rigel, in the constellation of Orion. Could Rigel surprise us and suddenly go supernova? There's something called the supernova problem that you should, probably know about because it may relate to Rigel going supernova or not. It seems that stars over 17 solar masses don't always go supernova. Recently, a red giant star simply vanished. Once again, it didn't go supernova, it disappeared. This had often been happening in computer simulations of supernovae, and now it finally occurred in real life. Rigel's mass is 21 solar masses. In other words, it's 21 times more massive than our Sun. So, will Rigel go supernova or simply vanish into a black hole that it'll create in its core? Astronomers and physicists continue their work of learning more about the dynamics of massive stars, scouring the sky for the next supernova in the Milky Way. Meanwhile, we can rest confident that we on Earth are in no danger from the harmful effects of nearby supernova explosions. We live in a nice, quiet, peaceful, stellar neighborhood, except for those Martians next door. Now really, an object weighing billions of times the mass of our Sun must be easy to find, right? Wrong. Unfortunately, it might not be that simple. like in the case with a missing black hole. But let's travel to the galaxy cluster Abell 2261, hosting a supermassive black hole at its center. Or at least, that's where it's supposed to be. The main problem is this giant space phenomenon is nowhere to be found. Now, supermassive black holes are mega monsters, churning slowly at the center of their home galaxies. They gather tremendous clouds of gas and dust around them, which makes them swell up to sizes the human mind can't begin to imagine. If a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved even a little bit closer to our solar system, we'd be doomed. The distance between this huge thing and Earth could be several dozens of light years, and still, it would wreak havoc on our planet. Earth, along with other things making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity or longer. Hey, who knows, right? So, it's good that such black holes stay away from us at the moment. So, let's see what happened to that runaway supermassive black hole from that gigantic cluster of galaxies around 2.7 billion years away from our planet. Scientists have been looking for it with the help of NASA's Chandra X-ray Observatory and Hubble Space Telescope. But so far, no result. The main problem with finding a black hole is that it's, black. And space is, you guessed it, black too. So there's no contrast whatsoever that could help astronomers spot the hole. But scientists haven't given up yet. After all, they have a lot of other technologies to find black holes, small and big, in the vastness of space. Some of these methods involve watching the stars orbiting black holes. Sometimes it's a faint gravitational wave signal, which is produced when two black holes collide. But the most reliable technique is watching dust and gas falling to their doom. The thing is, black holes are space objects with insane gravity. So, regions of space surrounding them are usually a bit chaotic, gas and dust getting pulled into the bottomless abyss, compressing and heating up. In the process, it releases a flood of X-ray radiation. So, astronomers look for extremely bright X-ray sources in the universe. Chances are those are the last gasps of giant clumps of material before they disappear into a black hole. Then, why can't scientists find such X-ray signatures left by the black hole in Abell 2261? One of the most mysterious things about its disappearance is that radio telescopes have spotted some signs of massive plumes of superheated material launched at one point within the last 50 million years. These plumes were most likely caused by a large black hole, which is nowhere to be found these days. So, at the moment, we can only play a guessing game. Maybe two medium-sized black holes collided, pushing the newly merged giant out of the center of the galaxy. The observations of the stars in that galaxy have shown a clump of dense material a few thousand light-years away from the galaxy's core. Maybe it's the runaway black hole, but disappointingly, no X-ray signals are coming from that clump. Or the hole might still be there in its rightful place, but it's, slumbering. If it doesn't get a fresh supply of gas and dust, it has nothing to feed on. As a result, it can't release a flood of X-rays. But again, the answer, do not disturb, the black hole is sleeping now, isn't very satisfying. Why isn't it getting its space food? What happened 50 million years ago? What is that clump of material speeding away from the galaxy center? So many questions, and no answers so far. At least, we know what black holes look like. Well, kinda. It's actually the shadow of a black hole's event horizon, visible against the glowing superheated material falling inside the hole. The first ever mugshot of a black hole appeared in 2019, but the data for its creation was collected in 2017. It took an international team consisting of more than 200 astronomers 2 years to assemble the image. We can admire this amazing space phenomenon thanks to a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Why such a name? The thing is that the event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape the black hole's clutches. Anyway, to capture that very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 powerful radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, to keep the chances of rain and bad weather to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. On each observation day, the telescope gathers roughly 350 terabytes of data. That's 10 times the amount of data collected every day at the Large Hadron Collider. But let's speak more about black holes themselves. There are stellar black holes, smaller but even more dangerous than their supermassive peers. They appear when stars that have run out of their star food fall into themselves. If a star used to be big enough, it keeps compressing and compressing some more, and voila! A baby stellar black hole is born. But even if I call such a hole a small one, it's still 5 to several tens of times heavier than the Sun. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 SUVs. One theory claims tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple mini black holes pass through our planet every day. There is a supermassive black hole smack dab in the middle of our galaxy, the Milky Way. Its name is Sagittarius A star, and it's 4.3 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light-years from Earth, too far to have any influence on our planet. By the way, recently, astronomers have discovered that this supermassive black hole might be leaking. If it's true, it probably means that Sagittarius A star isn't a sleeping giant, as previously thought. It might still be active. And the leakage recorded by scientists may be the hole hiccuping while swallowing clouds of gas. Maybe we should burp this baby? If you ever find yourself near a black hole, get ready that time will significantly slow down. It may work for you if you aren't eager to grow older. Just don't let yourself be tugged beyond the point of no return. Another danger of hanging around a black hole is that it might start behaving like a massive galactic volcano. From time to time, black holes flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short time ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Okay, mind blown, I'm out of here.
It's been more than a year since the James Webb telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place, and Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR 124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
What would the Earth look like if it was born in another solar system? I did a little research for you to find out, and the results were surprisingly wholesome. There are some warm tropics, strong winds, and giant dragonflies. But okay, let me explain from the very beginning. Since 1995, NASA has discovered more than 4,100 planets outside the solar system. Unfortunately, most of them are either flying ice balls like Neptune or gas giants like Jupiter. But there are still as many as 161 planets similar to our Earth. And one of them is very close to us, in the Alpha Centauri constellation. There are 3 stars in this constellation. 2 of them are called Alpha Centauri A and Alpha Centauri B. If you live in the southern hemisphere, you've probably seen them. They're very bright. Because of that, they look like one big star. They rotate around each other very slowly. And there's the 3rd star, chilling around not far from them. It's a teeny tiny red dwarf, Proxima Centauri. It got its name because of its proximity to our Sun. This star is the most interesting one, so let's talk more about it. Proxima Centauri is only 4.5 light years away from us. Oh, and 1 light year is about 6 trillion miles. Yep. If we went there, it would have taken just a little over 165,000 years of traveling in a space shuttle. Oh, you think that's a lot? For the universe, it's like checking on your fridge. Proxima Centauri is much lighter and much smaller than the Sun. It's also 2 times colder than the Sun, with a temperature of 3,000 Kelvin. That's why we can't see it without a telescope. On the bright side though, it will burn for trillions of years, and you don't have to worry that one day it will eat us like our Sun. And yes, our twin planet is located right next to Proxima Centauri. This planet is called Proxima b. Yeah, I know, they got creative with all these names. I hope you won't get confused. It's slightly larger and more massive than the Earth. This planet is located in the habitable zone of Proxima Centauri. It means that there can be water and even some microorganisms there. Yes, it's possible that one day we'll find some life there. But right now, we don't know much about this mysterious planet. It's probably a rocky planet like our Earth and has a similar landscape, but this is just a theory. Who knows what kind of jokes the universe can throw at us? It would be a shame to fly 165,000 years just to stumble upon a giant piece of ice or something. Fortunately, we probably don't have to wait that long. The big brains are now developing a technology that would allow us to move at the speed close to the speed of light. If they succeed, we'll get to Proxima b in just 20 years. But anyway, this video is not just about Proxima b. It's about what would have happened if life had originated not in our solar system, but in Alpha Centauri. What if we were orbiting Proxima Centauri, or the other two stars? So now, let's imagine that the Earth has replaced Proxima b. I'm going to call this new planet New Earth. Guess I'm not very creative at naming either. First of all, the orbit. The new Earth must be about 25 times closer to its star than Proxima b is. Otherwise, it would be unimaginably cold. Let's move the planet a little closer. Excellent. The day still lasts 24 hours, but our orbital period is very high. Proxima b revolves around its star in 11 days. But we'll make it in just 8. Hey, a birthday party every week? Sign me up. Oh, hold on. There's another problem. You see, Proxima Centauri is a flare star. This means that sometimes, just out of nowhere, it throws out some stellar winds. These winds carry around a bunch of ionized particles, which then settle on the planets. Yeah, our Sun also does that, but Proxima Centauri tries to finish us off 2,000 times harder than our Sun, so the radiation levels are off the scale, to say the least. Don't worry, it's fine. All we need are incredibly strong magnetic fields. They will help us create a very thick atmosphere that can protect us from the Proxima Centauri's tantrums. So now it's going to be very warm. Or not. Another problem. Scientists are still not sure how exactly Proxima Centauri's planets rotate around it. What if they turn out to be tidally locked, like our moon? Then one half of the new Earth will be a frying pan, and the other half will be some frosty deserts. Oh, it's fine, we'll just settle down somewhere in the middle. Didn't expect that I would ever say this, but it will definitely be warm at the North Pole. And if we're lucky with the rotation, we'll just get a cozy, warm planet. The average temperature is about 70 degrees Fahrenheit, and there aren't any extreme temperatures. On the new Earth, we have much more water. The weather is generally pretty crazy. Some very strong winds and quite destructive rains that can go on for quite a long time, but you can adapt. Temperature changes are much more noticeable in the mountains. Just like on Earth, the higher you climb, the colder it gets, except it's very cold right here at the top. Because of this, the mountains and hills have jungles below and snow-covered deserts on the tops. But in general, it's almost like the Earth's tropics. The flora is very rich, the trees are very low but lush. The thick atmosphere also makes flying easier, so there are a lot of large flying animals, like dragonflies with a wingspan of 16 feet. Moving on. The sky here is much lighter than that on Earth and very cloudy. Sometimes it may seem completely white. But the starry night is beautiful and bright. There are 4 suns. Our main one is Proxima Centauri. We can also see 2 bright Alpha Centauri stars. And finally, our old sun, which looks like a bright, distant star. I'll allow you to shed a tear for the old Earth. There's a few planets near us, like Proxima Centauri c. The host star is surrounded by 2 belts of cosmic dust, so get ready for some gorgeous, colorful night views. So what we have in the end is a little crazy, but a beautiful green planet. I personally wouldn't mind moving there already. What about you? Write in the comments. Alright, so now we know what would have happened if our Earth had been born near Proxima Centauri. What about the other 2 stars? Unfortunately, we won't be able to rotate near 2 stars at the same time. Scientists suspect that Alpha Centauri A and B have some kind of common planet that jumps from one orbit to another, but it's probably very cold. Let's choose Alpha Centauri A. Just like on the new Earth, here our average temperatures are about 70 degrees Fahrenheit. But now, the temperature variation is quite large. It goes from negative 100 degrees Fahrenheit at the South Pole to 113 degrees Fahrenheit at the equator. We'll be fine close to the north. The day is still 24 hours, and the orbital period is 1 year and 1 month. It's almost the same for the Alpha Centauri b, but the orbital period is about half a year. Other conditions are very similar to those on Earth. Changes in the seasons are almost not noticeable. The temperatures don't change much either. No matter where we settle down, the neighboring star will be clearly visible, but we probably won't see Proxima Centauri. And that's about it. Of course, all this assumes perfect conditions. Just like on Earth, one slightest change, whether it's a thin atmosphere or a bigger distance from the star, and it won't end well. We got really lucky with our Earth. But even so, the chances of finding a habitable planet are very high. Even with the tiniest possibility, there will be about 15 million planets in our universe that we can find life on.
When you explode planets, things get red hot. Atmospheres are stripped away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Some time before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart. And then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume. And finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains, covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1,600 of them. Unfortunately, you won't be able to do that because you press the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust. Then you spot bright burning meteors flying towards you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 1,200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach the blue marble of your home planet. What will its insides look like, scattered in space? From above, Earth looks pretty. 71% of its surface is blue, because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume. you see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 feet thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then the flying pieces get solid again. Ah, it's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 degrees Fahrenheit. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong, it evaporates smaller planets like Mars and Earth. The sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful, gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water, ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of the ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way, Neptune. It looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why, after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals.
Castles were cold places in times past. The stone seemed to radiate the winter chill. This is one practical reason why tapestries were hung upon castle walls, to help keep the cold out and the warmth in. But you just can't hang any old thing on castle walls. It should be beautiful, heroic, with a heavy wow factor. The ancient Greeks hung tapestries on the walls of their castle of the sky, glorious tapestries woven of stars. All 48 constellations of the Northern Hemisphere were designed and named by the Greeks. The story of Andromeda is one such tapestry, woven of 7 constellations spread across the entire autumn sky. The story contains detailed astronomical observations preserved as highlights in the sky tapestry. It begins with the constellation Cassiopeia, queen of the oldest realm in Africa, Ethiopia. When the constellation Cassiopeia is on the horizon, it looks like a staircase going up to the Milky Way. Step pyramids around the world are often thought to have been inspired by the constellation Cassiopeia. In any case, Cassiopeia is a beautiful constellation, indicating that Queen Cassiopeia was also a beautiful woman. She was good-looking, but equally vain, which sets off all the dramatic action. Cassiopeia can be found in the night sky opposite Ursa Major from the North Star. Like Ursa Major, Cassiopeia circles the North Star and is a circumpolar constellation. A supernova was observed in Cassiopeia around 1680 Earth time, Cassiopeia A having occurred about 11,000 years earlier. The Chandra X-ray satellite recently recorded an extraordinary photograph of this supernova remnant, showing the elements sulfur, calcium, silicon, and iron amid the expanding cloud's high-intensity X-rays. Cassiopeia's husband is also a circumpolar constellation, a minor, dim one named Cepheus. He had his own kingdom. A merger of empires by way of marriage is something common throughout history. Cepheus was a king of Phoenicia. There were many kings of Phoenicia back in the days when Phoenicia was just a collection of city-states along the western shore of the Mediterranean Sea. Cepheus can be found in the area between Cassiopeia and the North Star. The constellation of Cepheus is important to astronomers. It's where Henrietta Swan Leavitt discovered variable stars that pulsed at regular intervals. The rate of pulsation of the star indicates the true brightness of the star and enables a sure measurement of the distance to the star. The discovery of Cepheid variable stars was a major breakthrough for early 20th century astronomy. Cepheus and Cassiopeia had a daughter, Andromeda, also a noted beauty, about whom all the fuss is. It seems that one day Cassiopeia was boasting about the beauty of her and her daughter Andromeda. "We are more beautiful than any other women in the whole wide world." Well, such pretension can be forgiven for a queen. But then Cassiopeia went further and stepped beyond all natural bounds. In fact, we are more beautiful than any of the Nereids. Well, the Nereids were Greek mythological sea nymphs, daughters of the ocean. Noted for their beauty and kindness to sailors, the Nereids, all 50 of them, took offense at being dissed by a mere mortal woman. Cassiopeia had to be punished for exceeding the bounds of the civil order. By her excessive vanity, Cassiopeia transgressed beyond the bounds of nature, for which an unnatural punishment was inflicted upon the entire kingdom of Ethiopia. A monster from the bottom of the ocean, the constellation Cetus, began to devastate the coastal villages of Ethiopia as well as Ethiopia's fishing ships. Fittingly, Cetus is a constellation of the southern celestial hemisphere. The fourth largest by area of all the constellations, Cetus swims in a dark part of the sky called the ocean, with only its head rising above the celestial equator. This part of the sky contains several water-themed constellations: Pisces, the fishes, Aquarius, the water-bearer, and Eridanus, the river. Over 50 exoplanets have been discovered in Cetus. You can bet the James Webb Space Telescope will have a field day analyzing the spectra of these planets' atmospheres, looking for signs of life. Meanwhile, Queen Cassiopeia and King Cepheus must do something about the monster devastating the shores of Ethiopia. They consult an oracle and make another trespass beyond the realm of reason and nature. Tell us, oracle, what can we do to stop the monster from ravaging our kingdom? This monster is not a normal affliction of nature. An offense was committed against the higher realms, and this is the punishment. The monster cannot be stopped by any normal means. Only a human sacrifice of the noblest being may placate the beast. One error compounds another. The noblest person in the kingdom, of course, is Princess Andromeda. According to the command of her father and the consent, or perhaps a suggestion of her mother, Andromeda is chained to a rock offshore. She is the human sacrifice that her parents hope will save the kingdom. Wow. Da-da-da-da! Here comes the Greek hero to save the day, stop the human sacrifice, and turn Cetus to stone. Perseus. Now, where is Perseus coming from? According to legend, the Hebrides. Perseus went to the Hebrides in pursuit of the Gorgon Medusa. The geological scope of this tapestry is incredible, from the Hebrides to the Red Sea. The Hebrides are an archipelago of mostly rocky islands off the western coast of Scotland. It was impossible to sail any further. The Hebrides were the absolute end of the world. Perseus didn't have to sail to the Hebrides. However, he flew on a pair of winged sandals. Hey, way to go, Perseus! Now, Medusa was one of the all-time baddies. One look at Medusa was so terrifying it would petrify you, literally turn you to stone. Perseus was in great danger. So, what did our hero do? Instead of looking at Medusa, Perseus used the scientific principle of reflection. He slew Medusa by seeing her reflected in his polished shield. In our sky tapestry, Perseus is portrayed holding up the severed head of Medusa. In the night sky, one eye in Medusa's head opens and closes and opens again. Arabic astronomers named the star Algol, the ghoul. Algol is an eclipsing double star. One star is bright, the other one, not that much. As the dimmer star orbits the bright star, it passes in front of the bright star, eclipsing it, and the eye closes. Since the dim star takes 2 days, 20 hours, and 49 minutes to orbit the bright star, the eye in Medusa's head opens every day and a half or so. The constellation of Perseus is immediately below Cassiopeia, and skywatchers quickly look to see if Algol is eclipsed, if Medusa's eye is open or closed. Perseus flew back from the Hebrides, accompanied by Pegasus, the winged horse. The central part of Pegasus is the Great Square, made up of 4 stars. As Earth goes around the Sun, the Great Square is right in the center of the night sky in autumn. In the summer triangle of Vega, Deneb, and Altair are in the middle of the night sky. In spring, it's Leo the lion, and in winter, it's Orion the hunter. These are the walls of the castle in the sky, and all have marvelous tapestries adorning them. The constellation of Andromeda shares a star named Alpheratz with Pegasus. It's one of the corners of the Great Square, so it appears Andromeda may be riding on Pegasus. Her crown, remember she is a princess, is floating nearby. M31, the Andromeda Galaxy. To see M31, cross the corners of the Great Square from the lowest star to the uppermost star, and then go a little further to see the Andromeda Galaxy. Be sure to peek at it from the corner of your eyes. It's called averted vision. The corners of your eyes are more sensitive to light, so you'll be able to see the huge spiral galaxy 2.5 million light-years away as a smudge of light 1.5 times wider than the full moon. Now, Perseus doesn't go in for human sacrifice, so he stops it and saves Andromeda by exposing Cetus to Medusa's gaze. And here we encounter the second eclipsing variable in our sky tapestry, Mira, the heart star of Cetus, the sea monster. Mira, from which we get the English word mirror, so fitting in a story about vain beauty, is an eclipsing double star. The dim star orbiting the bright star is a white dwarf, not bright enough to see with the unaided eye. The effect is that Cetus's heart shuts off. Mira is eclipsed and disappears. This cycle repeats itself every 332 days. Our fabulous star tapestry has the only 2 eclipsing binary stars visible to unaided eyes, the nearest spiral galaxy, and a hero that doesn't like human sacrifice and uses the scientific principle of reflection to thwart mythological monsters. Wow, I would hang that in my castle too. Just saying.
Betelgeuse, a red supergiant. This ball of boiling plasma is one of the largest stars in our galaxy and one of the brightest. It's about 500 times larger than the Sun. But Betelgeuse is pulsating, getting bigger and smaller. At its peak, it becomes 800 times its average size. If this star were a bucket, it would fit about 300 million suns, even though its weight is only 17 times greater. And here, about 500 light-years away, is Earth. We launch our faster-than-light spaceship and set off on our journey to Betelgeuse. A few seconds, and we've already traveled 240,000 miles, and now are close to the Moon. That's 9.5 trips around the Earth. A traditional rocket-powered spacecraft would take 3 days to get here. We're near Mars now. The flight to the red planet usually takes about 7 months. Several rovers are now at work here, as well as the first ever flying drone, Ingenuity. The surface of Mars is 3 times smaller than that of Earth. The planet is also 10 times lighter. People hope to build a human colony here soon. Right beyond Mars, we have to wiggle and constantly dodge space rocks. This is the asteroid belt. It contains debris and space objects of different sizes and shapes. The biggest of them is Ceres. Its surface is slightly larger than the area of Argentina, and its weight is about 1% of the Moon's. The total weight of the entire asteroid belt is 25 times less than the Moon's. Next, we pass gas giants Jupiter and Saturn. These are the largest planets in the solar system. They're also the heaviest, even though they don't have a solid surface. Then, we travel by Uranus and Neptune. They're called ice giants. And at the very edge of the solar system, we see Pluto. It was once considered a full-fledged planet, but now it's not even on the list. After that, we're 4.3 billion miles away from our home. It took the New Horizons space probe about 9 years to get here. Hold on to your seat, we are speeding up! We're passing through the Kuiper Belt. There are lots of asteroids and blocks of ice here. These are some of the oldest building materials in our solar system. Billions of years ago, our whole world looked like a cloud of these asteroids. We're traveling further through dark space and reach the edge of the solar system, the heliosphere. All this time, we've been moving with the solar wind. But now, it starts to slow down, collides with the interstellar wind, and heats up. This is called the termination shock. The Voyager 1 space probe got to this point in December 2004. We're moving to the region where the heliosphere ends and interstellar space begins. This is the heliopause. In 2012, Voyager crossed this boundary and became the first ever human-made object in interstellar space. But the message from Voyager reporting this event came to Earth almost a year later because of the huge distance. It took 35 years for Voyager 1 to travel all this way. And here it is. The probe is as long as a car and weighs like 2 motorcycles. You can see a gold plate on its hull. It's a message from people to potential civilizations out there. It has pictures of Earth's landscapes recordings of human speech, and our DNA. As of 2021, Voyager has been operational for almost 43 years. The probe has traveled 14 billion miles. That's like 152 Earth to the Sun distances. And it's still making its way through space at 38,000 miles per hour. Now, we're approaching the nearest star to our solar system. It's Proxima Centauri. We're so far from home that even light needs more than 4 years to travel this distance. If we used a traditional rocket, the trip would take us 73,000 years. The reason we wanted to get here was because of an Earth-like planet called Proxima Centauri b. It's 10% larger than Earth and slightly heavier. It lies in the habitable zone of its host star. It means that water might exist on the planet in its liquid state, and there can be life that forms here. But the star itself occasionally produces flares. Recently, its brightness increased almost 1,000 times. During that time, it emitted so much radiation that even if there were some forms of life on the planet, they probably ceased to exist. We're now more than 8 light years away from Earth. The brightest star in our night sky is Sirius. Seriously. It's so bright that you can see it even during the day. But in reality, there are actually 2 stars, Sirius A and B. They orbit around a common center of gravity, and these stars are moving toward our solar system at almost 5 miles per second. That's the same as the maximum speed of a top-of-the-line supercar on Earth. Foot down, and we've arrived at a potentially habitable planet 39 light-years away from Earth. This is TRAPPIST-1d. Its host star is a white dwarf. It's a cold star, 10 times smaller and lighter than the Sun. There are 7 planets around it, but TRAPPIST-1d is the most similar to Earth. It's only 30% smaller and 3 times lighter, but it has a rocky surface and the temperature here is 48 degrees Fahrenheit. You'd feel comfortable here wearing a light jacket. There might be an atmosphere, mountains, seas, and oceans here, which means this planet might be suitable for a human colony. But it would take about 677,000 years to get here using traditional rockets. And here's our main goal, Betelgeuse. It'd take nearly 8.7 million years to travel here from Earth in a current-day spacecraft. This star is so big that our ship looks like a grain of sand on a giant beach. We have to jump back in time to find out what happened to this star. First, there was a beautiful nebula. It's a cloud of multicolored space dust and debris. Then, it began to shrink under its own weight. In the core of the nebula, a nuclear reaction began. Boom! And the star was born. At first, Betelgeuse was very massive and hot, but it didn't expand and remained stable. Let's look into its heart. The nuclear reactions in the star's core create a lot of heat and energy. This energy produces the force that pushes on the walls of the star from the inside and causes it to expand. But at the same time, the star is very heavy. That's why gravity pushes on it from the outside. If these 2 forces are balanced, the star remains stable. But over time, the star runs out of its fuel, helium and hydrogen. That's when heavier elements in the core join the nuclear reaction. When they burn, they release more energy and heat than gravity can hold, and the star starts expanding. That's what's happening to Betelgeuse right now. It's already so big that if you put it in the center of our solar system, its edge would touch the asteroid belt between Mars and Jupiter. Betelgeuse will continue to expand until it exhausts its fuel completely. Then the gravity will win. The star will shrink in size, and then an enormous boom will happen. A supernova explosion will be so blinding that Betelgeuse will shine brighter than the moon in the night sky. Luckily, Earth is too far away for this explosion to cause any harm to people. A strong stream of matter that will be ejected from the explosion site won't reach the solar system until 6 million years later. Even so, the solar wind will stop this flow, so we'll be safe. Betelgeuse is likely to explode at any time in the next 10,000 years. But some scientists say it won't happen in the next 100 millennia. Back to the moment before the explosion of Betelgeuse. There can be another, more interesting scenario. Gravity might compress the massive core of the star with such force that a black hole will appear in its place. Black holes are the heaviest objects in the universe. They have incredible gravitational force. Even light can't escape their gravitational trap. the Betelgeuse black hole will begin feeding on cosmic dust and whatever is left of the star. All this debris and light from other stars will get frozen near the event horizon of the growing black hole. For the first time in history, we'll be able to watch the birth of this mysterious object. But in reality, Betelgeuse is too light to become a black hole. Most likely, after the explosion, it'll turn into a white dwarf that will gradually fade until it becomes invisible.